National Electrical Code Section 400.85 states that cords and cables cannot be installed above suspended ceilings. This is generally because the space above a suspended ceiling is not considered a plenum unless specifically designed and designated as such, and is not suitable for the installation of electrical equipment using cord and plug connections. There are exceptions to this rule, as outlined in Section 400.7. Section 400.7 outlines the permitted uses for flexible cords and cables. However, the exception listed in 400.78, which allows cords and cables above suspended ceilings for luminaires, ceiling fans, and similar equipment, does not extend to wireless network transmitters. A wireless network transmitter is not considered similar equipment to luminaires or ceiling fans in the context of this code section. The primary purpose of luminaires and ceiling fans is lighting and air circulation, respectively. These are relatively simple functions compared to the complex electronic functions of a network transmitter. The code intends to limit the types of equipment allowed in these spaces to those with a proven safety record and minimal risk of causing a fire or other hazard. The fact that the wireless network transmitter comes with a cord and plug does not override the requirement to comply with 400.85. The presence of a cord and plug often indicates that the equipment is intended for portable or temporary use, but this does not automatically make it compliant for permanent installation above a suspended ceiling. In situations where the code prohibits the use of a cord and plug, the equipment must be hardwired. This involves directly connecting the equipment to the building's electrical system using appropriate wiring methods and junction boxes. Hardwiring ensures a secure and permanent connection, reducing the risk of accidental disconnection or damage to the cord. To properly install the wireless network transmitter, firstly, the cord and plug must be removed. Secondly, the equipment should be connected to a dedicated circuit, ensuring that the circuit breaker is properly sized to handle the load. Thirdly, use appropriate wiring methods such as conduit or cable to run the wiring from the circuit breaker panel to the location of the transmitter. Fourthly, install a junction box near the transmitter and make the necessary connections inside the box, ensuring that all connections are secure and properly insulated. Fifthly, ensure the junction box is accessible for future maintenance and inspection. It is important to consult with a qualified electrician to ensure that the installation complies with all applicable codes and regulations. Failure to comply with the electrical code can result in fines, insurance issues, or safety hazards. The NEC provides specific guidelines for wiring methods, grounding, and overcurrent protection to ensure the safety of electrical installations. When selecting wiring methods, consider the environment and the potential for physical damage. Conduit provides the best protection against physical damage, while cable may be suitable for less demanding environments. Grounding is essential for preventing electrical shock hazards. The grounding system must be properly installed and maintained to ensure that any fault current will safely flow back to the source, tripping the circuit breaker. Overcurrent protection, such as circuit breakers or fuses, is designed to protect the wiring from overheating and causing a fire. The overcurrent protection device must be sized appropriately for the ampacity of the wiring and the load it is serving. In addition to the NEC, local codes and regulations may also apply. It is important to check with the local electrical inspector to determine if there are any specific requirements for the installation of electrical equipment. Some jurisdictions may require a permit before any electrical work can be performed. Obtaining a permit ensures that the installation will be inspected and approved by a qualified electrical inspector. Regular inspections can help identify potential problems before they become serious hazards. In summary, while a wireless network transmitter may come equipped with a cord and plug, this does not permit its installation above a suspended ceiling in violation of NEC Section 400.85. The equipment must be hardwired in accordance with the code, ensuring a safe and compliant installation. Always consult with a qualified electrician and adhere to all applicable codes and regulations to ensure the safety and integrity of the electrical system. Furthermore, the NEC addresses various aspects of electrical installations, including wiring methods, grounding, overcurrent protection, and equipment installation. Understanding these requirements is crucial for ensuring electrical safety and compliance. Wiring methods refer to the types of conductors and raceways used to carry electrical current. Common wiring methods include conduit, cable, and wireways. Conduit provides the highest level of protection against physical damage and is often required in commercial and industrial settings. Cable is a more flexible option that is suitable for residential and light commercial applications. Wireways are enclosed channels used to protect and support conductors in exposed locations. Grounding is a critical safety measure that provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock hazards. The grounding system consists of a grounding electrode, grounding conductors, and equipment grounding conductors. The grounding electrode is typically a metal rod or plate buried in the earth, which provides a connection to the earth. Grounding conductors connect the grounding electrode to the electrical system, ensuring that all metal parts are grounded. Equipment grounding conductors connect the metal enclosures of electrical equipment to the grounding system, providing a path for fault current to flow back to the source. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the wiring from overheating and causing a fire. Circuit breakers are automatic switches that trip when the current exceeds a predetermined level. Fuses are one-time devices that melt and break the circuit when the current exceeds a predetermined level. The overcurrent protection device must be sized appropriately for the ampacity of the wiring and the load it is serving. Equipment installation requirements vary depending on the type of equipment and the location. The NEC provides specific guidelines for the installation of various types of equipment, including luminaires, motors, transformers, and appliances. These guidelines address issues such as clearances, ventilation, and support. In addition to the NEC, local codes and regulations may also apply. It is important to check with a local electrical inspector to determine if there are any specific requirements for the installation of electrical equipment. Some jurisdictions may require a permit before any electrical work can be performed. Obtaining a permit ensures that the installation will be inspected and approved by a qualified electrical inspector. Regular inspections can help identify potential problems before they become serious hazards. In addition to the basic electrical requirements, there are also specific requirements for installations in hazardous locations. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. The NEC provides specific guidelines for the selection and installation of electrical equipment in hazardous locations. These guidelines are designed to minimize the risk of ignition and explosion. The NEC also addresses the issue of energy efficiency. The code requires the use of energy-efficient lighting, motors, and appliances. These requirements are designed to reduce energy consumption and lower utility bills. Furthermore, the NEC is constantly evolving to keep pace with new technologies and changing industry practices. The code is updated every 3 years to reflect the latest advancements in electrical safety and energy efficiency. It is important to stay up to date on the latest code changes to ensure that electrical installations are safe and compliant. To ensure compliance with the NEC, it is recommended to consult with a qualified electrician. A qualified electrician has the knowledge and experience to properly install and maintain electrical systems in accordance with the code. A qualified electrician can also provide guidance on energy-efficient lighting, motors, and appliances. In conclusion, the NEC is a comprehensive set of guidelines for electrical installations. Adhering to the NEC is essential for ensuring electrical safety and compliance. By understanding the basic requirements of the NEC and consulting with a qualified electrician, it is possible to create a safe and efficient electrical system. When dealing with electrical installations, it is crucial to prioritize safety above all else. Electricity can be dangerous if not handled properly. Always follow safety precautions when working with electricity, and never attempt to perform electrical work unless you are qualified to do so. If you are unsure about any aspect of electrical work, consult with a qualified electrician. Remember, electrical safety is everyone's responsibility. By following safety precautions and adhering to the NEC, it is possible to prevent electrical accidents and protect lives. Additional considerations for installing electrical equipment above suspended ceilings include: firstly, ensuring adequate ventilation to prevent overheating, especially for devices that generate heat. Secondly, verifying the load-bearing capacity of the ceiling grid to support the weight of the equipment and any associated hardware. Thirdly, implementing proper cable management to prevent tangled or stressed wiring, which could lead to connection failures or fire hazards. Fourthly, using appropriate fire-rated materials for any enclosures or supports to maintain the fire resistance rating of the ceiling assembly. Fifthly, complying with accessibility requirements for maintenance and inspections, ensuring that the equipment can be safely reached without disrupting other ceiling components. Sixthly, avoiding the placement of electrical equipment near water pipes or other potential sources of moisture to prevent corrosion or electrical hazards. Seventhly, properly labeling all electrical components and wiring for easy identification and troubleshooting. Eighthly, coordinating with other trades, such as HVAC and plumbing, to ensure that the electrical installation does not interfere with their systems. Ninthly, conducting thorough testing and commissioning after installation to verify proper operation and safety. Tenthly, providing training to building occupants or maintenance personnel on the operation and maintenance of the installed equipment. These additional considerations, combined with strict adherence to the NEC, contribute to a safe, reliable, and code-compliant electrical installation above suspended ceilings. The National Electrical Code provides detailed requirements for electrical installations, covering a wide range of topics from wiring methods to equipment grounding. Understanding these requirements is essential for ensuring electrical safety and compliance. Section 300.11 of the NEC addresses securing and supporting wiring. This section requires that wiring be securely fastened in place and supported at intervals appropriate for the type of wiring method used. The purpose of this requirement is to prevent the wiring from becoming damaged or dislodged, which could create a safety hazard. Section 310.15 of the NEC covers ampacity calculations for conductors. Ampacity is the current carrying capacity of a conductor, and it is important to select conductors with sufficient ampacity to handle the load they will be serving. The NEC provides tables and formulas for calculating ampacity, taking into account factors such as conductor size, insulation type, and ambient temperature. Section 400.4 of the NEC specifies the permitted uses for flexible cords and cables. This section limits the use of flexible cords and cables to certain applications, such as portable appliances and temporary wiring. Flexible cords and cables are not permitted for permanent wiring unless specifically allowed by other sections of the NEC. Section 406.4 of the NEC covers receptacles. This section requires that receptacles be of the grounding type and that they be properly grounded. The purpose of this requirement is to prevent electrical shock hazards. Section 408.36 of the NEC addresses overcurrent protection for panel boards. This section requires that panel boards be protected by overcurrent devices, such as circuit breakers or fuses that are sized appropriately for the load they will be serving. The purpose of this requirement is to protect the wiring from overheating and causing a fire. Section 500.1 of the NEC covers hazardous locations. This section provides specific requirements for the selection and installation of electrical equipment in hazardous locations where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. The purpose of these requirements is to minimize the risk of ignition and explosion. Section 600.1 of the NEC addresses electric signs and outline lighting. This section provides specific requirements for the installation of electric signs and outline lighting, including wiring methods, grounding, and overcurrent protection. The purpose of these requirements is to ensure the safety of these installations. Section 700.1 of the NEC covers emergency systems. This section provides specific requirements for the installation of emergency systems, which are designed to provide power to essential loads during a power outage. The purpose of these requirements is to ensure that emergency systems are reliable and can provide power when needed. Section 701.1 of the NEC addresses legally required standby systems. This section provides specific requirements for the installation of legally required standby systems, which are designed to provide power to essential loads that are required by law to have backup power. The purpose of these requirements is to ensure that legally required standby systems are reliable and can provide power when needed. Section 702.1 of the NEC covers optional standby systems. This section provides specific requirements for the installation of optional standby systems, which are designed to provide power to non-essential loads during a power outage. The purpose of these requirements is to ensure that optional standby systems are installed safely and do not interfere with the normal operation of the electrical system. The NEC is a comprehensive set of guidelines for electrical installations, and it is important to consult the code for specific requirements related to your project. Always consult with a qualified electrician to ensure that your electrical installation is safe and compliant. In addition to the specific requirements of the NEC, there are also some general principles of electrical safety that should be followed. Always turn off the power before working on electrical equipment. Use insulated tools when working on electrical equipment. Never work on electrical equipment when you are wet or standing in water. Inspect electrical cords and equipment regularly for damage. Replace damaged cords and equipment immediately. Do not overload electrical circuits. Use ground fault circuit interrupters, or GFCIs, in areas where there is a risk of electric shock, such as bathrooms and kitchens. Install smoke detectors and carbon monoxide detectors in your home. Have your electrical system inspected regularly by a qualified electrician. By following these general principles of electrical safety, you can reduce the risk of electrical accidents and protect yourself and your family from harm. The proper installation of electrical systems is crucial for ensuring the safety and functionality of buildings. When installing electrical equipment, it is important to follow all applicable codes and regulations, including the National Electrical Code and local building codes. The NEC provides detailed requirements for electrical installations, covering a wide range of topics such as wiring methods, grounding, overcurrent protection, and equipment installation. Local building codes may also have additional requirements that must be followed. Before beginning any electrical work, it is important to obtain the necessary permits from the local building department. A permit ensures that the work will be inspected by a qualified electrical inspector who will verify that the installation meets all applicable codes and regulations. It is also important to plan the electrical installation carefully before beginning work. This includes determining the location of all electrical outlets, switches, and fixtures, as well as the size and type of wiring needed. A detailed plan will help to ensure that the installation is safe, efficient, and meets the needs of the building occupants. When installing wiring, it is important to use the correct type of wire for the application. The NEC specifies the types of wire that are permitted for different applications, such as residential wiring, commercial wiring, and industrial wiring. It is also important to use the correct size of wire for the load that it will be serving. The NEC provides tables that specify the ampacity of different sizes of wire. Grounding is an essential part of any electrical installation. The grounding system provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock hazards. The grounding system must be properly installed and maintained to ensure that it is effective. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the wiring from overheating and causing a fire. The overcurrent protection device must be sized appropriately for the ampacity of the wiring and the load it is serving. Electrical equipment must be installed in accordance with the manufacturer's instructions and all applicable codes and regulations. This includes ensuring that the equipment is properly supported, ventilated, and protected from physical damage. After the electrical installation is complete, it is important to test the system to verify that it is working properly. This includes testing the grounding system, the overcurrent protection devices, and all electrical outlets, switches, and fixtures. If any problems are found, they should be corrected immediately. Regular maintenance is essential for ensuring the continued safety and functionality of electrical systems. This includes inspecting the wiring, the grounding system, and the overcurrent protection devices on a regular basis. Any problems that are found should be corrected immediately. By following these guidelines, it is possible to ensure that electrical installations are safe, efficient, and compliant with all applicable codes and regulations. Always consult with a qualified electrician to ensure that your electrical installation is done properly. When dealing with electrical systems, it is important to remember that safety is always the top priority.